Space is vast. Traveling to other planets takes a very long time. A trip to Mars, for example, could take several years. This poses many challenges for astronauts. They would need a lot of food, water, and other supplies. They would also be exposed to radiation and the psychological effects of long-duration spaceflight. Cryosleep is a potential solution to these problems. It is a state of suspended animation. In cryosleep, an astronaut's body temperature is lowered. Their metabolism slows down. This would allow astronauts to sleep through the long journey to Mars or other destinations. They would need fewer supplies. They would be protected from radiation. Cryosleep is still in its early stages of development. However, it has the potential to revolutionize space travel. It could make long-duration missions more feasible. This could open up new horizons for human exploration. Cryogenic fluid management, or CFM, is essential for cryosleep. It is also crucial for many other aspects of space exploration. Cryogenic fluids are extremely cold. They are used as fuel for spacecraft. They are also used to keep instruments and other equipment cool. Liquid hydrogen and liquid oxygen are two of the most commonly used cryogenic fluids in space exploration. They are used as rocket propellants. They are also used for life support systems. These fluids need to be stored and managed carefully. This is because they can easily boil off and escape into space. CFM systems are designed to keep cryogenic fluids at their required temperatures. They also ensure that the fluids are delivered to where they are needed. These systems are complex and challenging to design and operate. However, they are essential for enabling long-duration space missions. Managing cryogenic fluids in the harsh environment of space presents numerous challenges. One of the biggest challenges is boil-off. Boil-off is the evaporation of a liquid due to heat ingress. Even with insulation, some heat will always leak into a cryogenic storage tank. This causes some of the fluid to boil off into a gas. Another challenge is sloshing. Sloshing occurs when a liquid moves around inside a container. This can happen during spacecraft maneuvers or when the spacecraft is docked with another vehicle. Sloshing can cause problems with the spacecraft's stability and control. Accurate gauging is also a challenge in space. It is difficult to measure the amount of cryogenic fluid remaining in a tank in a microgravity environment. Accurate gauging is essential for mission planning and safety. NASA is developing new technologies to address the challenges of CFM in space. One promising technology is the radio frequency mass gauge, or RFMG. The RFMG is a sensor that can accurately measure the mass of cryogenic fluids in tanks, even in low gravity. This technology is being tested for future missions to the moon. Another area of research is in advanced insulation materials and techniques. Better insulation can significantly reduce boil-off rates. This extends the time cryogenic fluids can be stored in space. NASA is also working on cryocoolers. Cryocoolers are small refrigerators that can be used to cool cryogenic fluids. For longer duration missions, NASA is exploring in-situ resource utilization, or ISRU. ISRU involves using resources found on the Moon or Mars to produce cryogenic fluids. This would eliminate the need to transport large amounts of fuel from Earth. These technologies are crucial for making cryosleep and long-duration space travel a reality. They represent a significant step towards expanding humanity's reach into the cosmos.